Hello everyone. So in this video we will talk about the axial stress or axial forces acting on the drill string at different sections of the drill string. This is important topic in terms of drilling engineering because you need to select the right basically size pipes, the right drilling string system that have the right properties in terms of the tension that can be applied to them and how much they can resist. So look at this system on figure 410A. This is figure 410 in the book, and let's say we have this system, right? And there is a drill pipe, right? And there is a drill collars attached to the drill pipe, and then there is a bit at the bottom, right? So the first thing that you need to understand is that the tension that is being applied at each point inside your at any depth inside your drill string and drill collar would be different from each other. So you don't have a constant tension from the top to the bottom. You have a variations of tensions inside your drill pipe and also variations of tension inside the drill collar, and in this video I'm going to talk how to calculate those. Okay, so let's first consider a drill pipe, right? And a drill collar, which is basically this bottom part, right? And the method to calculate this is basically a method which I call it cutting method, right? And cutting method means that if you want to calculate the tension at any point inside, for example, your drill collar, what you need to do is to cut. We change the color here. You need to cut from whatever depths that you want to calculate the tension at, and draw a free body diagram for that section. Okay, so for example, you want to calculate the tension at this point, right? So what you do is you cut it from here and you just consider the bottom part and you create a free body diagram from that section. Okay, so what you do once you cut, you add a force there instead of all the basically drill string on the top. You add a force, you call it F tension. That's the tension force that is being applied. Now if your tension force is negative, it's a compression actually, right? It's not a tension. So we'll see later that how these values are changing with depths from tension to compression, and where is basically the point that basically is neutral. So all right, so let's see this, right? So let's say you wanted to calculate this, right? And you cut this section. You make a free body diagram out of that, right? And instead of the whole top part, you put a F tension there, right? This is XDC that you're seeing it there as well, right? So that's the length of the drill collar, not the whole length, but from the bottom to that depth that you want to calculate the tension at, right? So what forces are being acted? One is of course, the weight, right? The weight of this drill collar, right, which is downward, right? There is a buoyancy force, of course, applied at the bottom, right? You see that there is a cross-sectional area, the drilling fluid is there, so there is a buoyancy force being applied upward, and F2 is a force basically which we call it, it doesn't have a name, but it's a support force. So let's say you have your system, drill string system, everything down, right? So initially you put your drill bit on the bottom of your wellbore, right? So you put some force on the bottom, so that's the normal force from the bottom of the wellbore acting on your drill bit. That's what it is. Okay, so the normal force, so you set this is the bottom part, right? Let's say this is your drill bit and this is the bottom that you haven't cut it through, right? So there is a normal force being applied from the surface to this system, right? It's kind of a supportive force, right? Now if your drill bit has a distance from the bottom, then there is no support force such as F2. Okay, so it appears only if you have your drill string and drill bit system on the ground at the bottom. okay? And that's why it's kind of dashed line, so you might have it or you might not have it. Usually we ignore it, but anyway. So now we have that, right? Makes sense so far. And this is basically the free body diagram for that. And what if you want to we will write the force balance later, but this is basically how you draw the free body diagram for that portion. Now let's say you want to calculate the tension in a part of your drill pipe. What do you do? In that case, you cut through whatever depths from the drill pipe you want to basically calculate the tension at, right? And once you cut it, you put again another force tension instead of the upper portion that you basically removed it, right? So there is a tension being applied, right? Now you have two sections. You have a drill pipe and then you have a drill collar at the bottom, right? So whatever area on the bottom, right? So drill pipe have a length, drill collar have a length. What force is being applied? There is a force by the weight of your drill pipe. There is a force by the weight of your drill collar. There is a buoyancy force being applied to the system. The whole object, F2 might be there. The support force from the rocks at the bottom, right? And also there are two areas here, right? Because the cross-sectional area of your drill collar is more than the cross-sectional area of your drill pipe. So there is an area here that the fluid can put a perpendicular force in the direction that we write the force balance. So this cross-sectional area, which is the difference between the cross-sectional area of your drill collar and drill pipe, should be considered as well, because there is a hydrostatic pressure being applied to that specific depth, and if you multiply that hydrostatic pressure to the cross-sectional area, which is the difference between the cross-sectional area of the drill collar and drill pipe, then there is a force being applied, and that is called F1 here. Make sense? So again, this is your drill collar, right? Let's say this is your drill collar section, and then you have your drill pipe, right? Well, basically, if I want to draw only this section, I shouldn't draw it this way, but that is, I guess, should be okay. I can draw it here for the whole section, for the both sides, basically, right? I could draw. Okay, let me redraw these things here. This is not good. All right, I'm gonna make it bigger. So let's say this is your drill collar. Usually have a very high steel area, right? So this is your drill collar, the whole pipe, right? And then you have your drill pipe, which is here, and have a thickness, right? We are drawing the thickness here. The dashed areas represent the thicknesses of that pipe specific. So this is the drill pipe sitting on the top of the drill collar, right? So once you look at this, you see that, okay, so you have this situation, right? And then there is an area in which is basically this area, right? The fluid is acting some force on it from the top view, right? Also this area, in general, the whole area, right? The whole area here, there is a force being acted perpendicular in this, right? So try to imagine what happens there, right? So you have a cross hydrostatic pressure here, and there is a cross-sectional area which is available for that pressure to be applied to, and we call that F1. So we write the force balance later for this one as well, so don't worry about that. And I guess I'm gonna stop here, and the way I'm gonna talk about it is through examples. Okay, so you'll see with examples how to exactly calculate these forces.